Today we are going to learn the concept of atomic size. We have learned that at the center of the atom is the nucleus, and there are moving electrons in the extranuclear part. The electrons are negatively charged particles, while the elementary particles that make up the nucleus are positively charged protons and electrically neutral neutrons. The size of an atom is determined by its radius. The atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. Atomic radius is expressed in nanometer. 1 upon 10 raised to 9 meter is equal to 1 nanometer, and 1 meter is equal to 10 raised to 9 nanometer. The atomic radius of hydrogen atom is 10 raised to negative 10 meter. The atomic radius of water molecule is 10 raised to negative 9 meter, and the atomic size of hemoglobin molecule is 10 raised to negative 8 meter. Atoms are very tiny, so modern instruments like electron microscope, ion field microscope and scanning tuning microscopes are used to study the ultrastructure of atoms. The atomic size depends on the number of electron orbits in the atom. Greater the number of orbits, larger the atomic size. For example, an atom of potassium is bigger than the atom of sodium. If two atoms have the same outermost orbit, then the atom having the larger number of electrons in the outermost orbit is smaller than the one having fewer electrons in the same outermost orbit. For example, atom of magnesium is smaller than the atom of sodium. Now let's begin with the atomic mass of an atom. The mass of an atom is concentrated in its nucleus. It is due to the presence of protons and neutrons. The number of protons and the number of neutrons inside the nucleus is said to be the atomic mass of an atom or atomic mass number. Protons and neutrons are together called the nucleons. Atom is very tiny, so it is very difficult to determine its mass. Scientists also struggle a lot to find out the atomic mass of an atom. In 19th century, it was very difficult to determine the atomic mass of an atom accurately. Therefore, the concept of relative atomic mass of an atom was introduced. In this, a reference atom was required for expressing the relative atomic mass. The hydrogen atom being the lightest was initially chosen as the reference atom. Relative atomic mass of hydrogen atom, which has only one proton in its nucleus, was accepted as 1. Therefore, the magnitude of the relative atomic masses of various atoms become equal to their atomic mass number. Let us see how to express the relative mass of a nitrogen. The mass of one nitrogen is 14 times that of a hydrogen atom. The relative mass of nitrogen atom is 14. This is how the relative atomic mass of various elements were determined. On this scale, the relative atomic mass of many elements came out to be fractional. Therefore, in the course of time, different atoms were chosen as the reference atoms. And finally, the carbon atom was selected as the reference atom. The relative atomic mass of carbon atom was accepted as 12. The relative atomic mass of one hydrogen atom compared to the carbon atom becomes 12 into 1 divided by 12. That is 1. The mass of one proton and the mass of one neutron on the scale of relative atomic masses is approximately 1. Today, we have highly accurate method for measuring the mass of an atom directly. Instead of relative mass, unified mass has been accepted as the unit of atomic mass. It is called Dalton. Expressed, its symbol is a small letter u. 1 Dalton is equal to 1.66053904 into 10 raised to negative 27 kg. The next topic, chemical symbols of an element. How is an element indicated in chemistry? Yes, the element is indicated with the help of symbols. Tell me some symbols of an element. Yes, hydrogen H, C represent the carbon, Ca represent the calcium, Mg represent the magnesium, Cu represent the copper, Zn represent the zinc, and many more. So Dalton used certain signs to represent the elements. For example, Dalton used the circle inside dot. This symbol Dalton used to represent the hydrogen. Second symbol Dalton used is that circle inside capital letter C. This symbol is used to represent the copper. Today we use the symbols determined by IUPAC, International Union of Pure and Applied Chemistry. These are official names and symbols and are used all over the world. The current method of choosing chemical symbols is based on the method invented by Berzelius. According to this method, the symbol of an element is either the first letter or the first and the second specific in its name of the two letters. The first is the capital letter and the second is small letter. Next, molecules of elements and compounds. Atoms of some elements such as helium, neon have independent existence. It means that these elements are in a monoatomic molecular state. Sometimes two or more atoms of an element combine to form molecules of that element. Such elements are in a polyatomic molecular state. For example, the elements oxygen, nitrogen are in a diatomic molecular state. When atoms of different elements combine with each other, the molecules of compounds are formed. The compounds are formed by chemical attractions between two